Hello and welcome again to our video, and for today's video it is to be a continuation of the sample problems under uniformly accelerated rectilinear motion. Okay, so in this example, so it is indicated here that a car is moving at a uniform acceleration. So after traveling for 2 seconds, it is found 12 meters from where it started. If the car's velocity is at 5 seconds is 10 meters per second, we would be determining the following. Okay, so before proceeding, let us first draw the problem for us to better visualize it. So suppose that this is now to be your car and it is to be moving along this direction. So with that, if this is now to be its initial position, it is said here that after 2 seconds, it is found 12 meters from where it started. So let's pretend that this is now to be its 12-meter mark. So 12 meters. Okay, and since it is said in the problem that the car is moving at uniform acceleration, it means that its acceleration is to be constant throughout. So in its acceleration here is to be the same as for this, after passing through this point. Okay, and it is also said here that the car's velocity at 5 seconds is to be 10 meters per second. So with that, so let's say that this is now to be, let's say it's a 5-second mark, just for pretend. So once again, for 12 meters, it has traveled 12 meters in a span of 2 seconds. So after 5 seconds, its velocity, so its v here, is now to be equal to 10 meters per second. Okay, so that is after 5 seconds. So at 5 seconds. So what that means is that from this point up until this point, so that is now to be your 5 seconds. So with that, this is now to be 3 seconds. So this from this point up until this point, that should be 3 seconds. Okay, so according to the problem, we are to determine the car's acceleration. Okay, so once again, the acceleration here is also the same as with the acceleration here. Okay, so going back to our list of formulas, so let's check regarding on what formula here we would be using. So if our acceleration is to be the one unknown, so we cannot use this any longer because, of course, there is no variable acceleration there. So we may use this equation here. However, we do not know the initial velocity. So in the problem here, so it is said here that the car is moving at a uniform acceleration and it is not starting from rest. So if it did not started from rest, the initial velocity is not equal to 0. So take note of that. Okay, so with that, we cannot make use of this. And what about for this second one? So for this second one, of course, we cannot also make use of this one here because we do not know the initial velocity of I. However, guys, so once again, for our method here, so our method, the method that I will be teaching you is not to be the only way in solving for, of course, the problem. So there are many ways. So if you can find a way for you to make use of this equation, then go. It's just that for this exact equation here, you cannot make use of it directly. Siguro magde-derive ka pa. So you would now be, let's say, having maybe 2 equations, 2 unknowns, and etc. Okay, how about for this one here? Okay, so we have the value for your x. We have the value for your VF. So let's assume that our VF is to be this. And we also know the value of your time. So actually, we do not know the value of our time directly. But with that, guys, so I can say that I can make use of this equation if I would now be manipulating it. So if I would be rewriting that equation here, so x is to be equal to VF times t minus a t squared over 2, whereas a is to be the one unknown. I can make use of this equation if I properly understood this figure. Okay, so what I would be doing is that I will be making use of this whole diagram here. So instead of dividing it into 2, so kapag ganyan kasi wala ka din lang ma-formulate na equation, so it is better just for me. So if you can find your own way, so edi good. And for me, what I would be doing is that I will be, combining these two. So for the value for your x, so that is now to be equal to 12 meters plus, let's say that this is now to be x2 for pretend. So with that, 12 meters plus, of course, your x2 is equal to Vf. So our Vf is to be 10 meters per second. So 10 meters per second times time. So time is already given. So 5 seconds. So times 5 seconds minus acceleration. So actually that is to be the one unknown. So acceleration times time squared. So 5 squared over 2. But as you can see, we have two unknowns. So we have a and we have x sub 2. So what is to be this distance here? So we can also make use of this particular equation just for us to get x sub 2. So with that, so note here that x sub 2 is equal to, so using this formula, so Vf is also the same, which is to be 10 meters per second. So 10 meters per second times time, and our time is to be equal to, so take note that in this particular distance, the time that has passed through there is to be just 3 seconds. So with that, 3 seconds. So 3 seconds lang to, guys. So the one that you're analyzing here is to be just this. And for this particular equation at the bottom part, it should be all of this. But take note, guys, that you can only make use of this formula if your acceleration here is to be the same as with your acceleration here. But for pretend that your acceleration here is not to be the same as with your acceleration here, dapat magkahiwalay mo silang i-analyze. So in English, you should analyze them separately. Okay, so proceeding here. So for our equation at the right side, so times 3. So minus 80 squared over 2. So minus acceleration. So we do not know acceleration yet. Times time. So once again, 3 seconds squared divided by 2. And since you cannot see what I am writing, so I will just be moving it here. So may sasakyang na isama, mamaya na yan. Okay. So with that, guys, I can actually substitute this value to x sub 2 here. So with that, I would just be copying all of this to our next slide for us to have space. Then i-erase ko lang ito. Oops, sorry. Okay, so substituting this value to this equation, so let's say that this is to be, of course, your equation 1 and equation 2. So sub equation 2 in equation 1. So this, we would now be having an equation of 12 meters plus x sub 2, and that is now to be equal to 10 meters per second times 3 seconds minus a over 2 times 3 seconds squared. So this is now to be equal to, so 10 meters per second times 5 seconds minus, so a divided by 2 times 5 squared. So actually, guys, I will just be writing this green for us to see that our value for a is to be the only one unknown. So with that, so I would just be making use of shift solve in my calculator. So if you want to solve for it via algebra, the better. So 12 plus 10 times 3 minus alpha x. So I'm assuming that our alpha x is to be our acceleration. So times 3 squared divided by 2 is equal to 10 times 5 minus alpha x over 2 times 5 squared. So getting the answer here. So shift solve, my answer is now to be equal to 1 meter per second squared. So with that, Our answer here for acceleration is to be equal to 1 meter per second squared. So what that indicates is that for every second, the velocity increases by 1. Okay, so there. Okay, so since we already know the acceleration, so I would just be erasing all of this since you already know the acceleration. So let us now proceed with the second sub-question. So according to this, from this question, we must determine its displacement at t equal to 5 seconds measured from its starting point. So with that, guys, let us now solve for this value of x. So with that, that is basically 12 meters plus x sub 2. So with that, so our x total is to be equal to 12 meters plus, of course, x sub 2. So going back to this equation, so our x sub 2 is to be equal to 10 meters per second times 3 seconds times a and etc. So I will just be rewriting it here. So ito nga yung x sub 2 natin, no? So let us just solve for x sub 2. So x sub 2 is to be equal to 10 meters per second times 3 seconds minus a, and since we have already solved for a as 1, so 1 meters per second squared times 3 seconds in quantity squared divided by 2. So our x sub 2 is now to be equal to, looking at the calculator to your left, so 10 times 3 minus 1 times 3 squared divided by 2. Our answer here is now to be equal to 25.5. So 25.5 meters. Okay, so with that, so our x total or x sub t at 5 seconds, so this distance here is now to be equal to 12 meters plus 25.5. So my answer here is now to be equal to 37.5 meters. So 37.5 meters. So this is to be my answer for letter B. So my x sub t is to be equal to 37.5 meters. So there. Okay. So it is said here in the problem for the next question that suppose that after 5 seconds, the car decided to slow down and stopped after traveling to a position 80 meters from the starting point. So we would now be determining its acceleration. Its deceleration. Okay, so with that, from the starting point up until, let's say, this point. So let's say that from the starting point up until this point. So let's say that this is now to be equal to 80 meters. From this point, after 5 seconds, the car decided to slow down. So with such, our acceleration is now to be different. So with that end, it decided to stop at this particular point. So if this is now to be 80 meters, if it started at this point, it means that our VF here at 80 meters is now equal to 0 because of course it stopped. So this is now to be its speed. So 0 meters per second. So what is now to be the deceleration? But let us solve for acceleration. And actually, guys, your deceleration is just to be your negative of your acceleration. Anyway, so proceeding, since we already know that your final velocity is just to be equal to your initial velocity plus the acceleration times the time. And with that, guys, so for your VF, this should be equal to 0 since we are assuming that it will be stopping at this particular point. So 0 meters per second is equal to, so what is now to be your VI? So is your VI, let's say, this particular velocity here? So no, because we are only considering this particular point. Okay, so if we are just to consider this particular point, so VI is to be 10 meters per second. So 10 meters per second plus A times t. However, we do not know the value of t. So it is either that we will be having two equations or two unknowns, or we will be making use of another equation. So in my case, I would just be using another equation. So going back here, so our acceleration is to be the one unknown. So acceleration is to be unknown. So we have the value for our VI, we have the value for our VF, and we also have the value for our X. So which of the following ones here has this, all of these parameters. So with that, it is safe to say that we can make use of this equation here, since we already have the value of VF, VI, and X, and we are actually solving for acceleration. So with that, so rewriting it here, so VF squared is equal to VI squared plus 2AX. So confirming VI squared plus 2AX. Okay. So with that, substituting known value, so for our VF, once again, it is equal to 0. And for our VI, so for our VI, so if you are wondering if it is to be this or this, of course, it would be this, because what I am going to do is just that I would be analyzing just this part. Kasi dyan pa lang siya nagsimulang bumagal. So in English, it is just to be in this point wherein the car decided to slow down. So with that, the VI, if this is now to be the part that you are analyzing, the VI there is just to be 10 meters per second. So ito na yung VI ngayon. So kanina VF siya if you are considering this. And this time, if you are considering this is now to be your initial velocity. So your initial velocity right now is to be 10 meters per second. So of course, you would be squaring this. So plus twice acceleration, so that is to be the one unknown, times x. So once again, I am only considering this distance. So not just, not the 80. So if this part of the, if this distance here, so if this distance here is now to be equal to 37.5 as solved earlier, it means that this part here, it means that this part of the distance here is to be equal to 80 minus 37.5. So with that, it is now to be equal to 42.5, I should say. So with that, this is now to be 42.5. Okay, so solving for this equation. So the acceleration is now to be equal to, so via shift solve once again, so 0 is equal to 10 squared plus 2 times alpha x times 42.5. So shift solve. Our answer here is to be negative 1.1765 meters per second squared. So to confirm, so I would check if this equation here is true. So 10 squared plus 2 times negative 1.1765 times 42.5. So our answer here is to be negative 0.0001. So it is negligible. So it is basically equal to 0. So this is now correct. So with that, our answer here for the deceleration. So take note, guys, that what is being asked in the question is to be its deceleration. So it means that it is now to be the negative value of course, your acceleration. So with that, your deceleration is now to be equal to 1.1765 meters per second squared. Okay. So though it is not indicated in the problem, so let us solve for VI at this particular point, or at this particular point. So with that, so let's determine, so let us add another question. So let's say D. Determine velocity at time equal to 0 seconds. So with that, guys, let us just consider this part. So if we are just to consider that part, so I'll just be clearing this. If I am just to consider this part, so we already have the value for VF and for our VI, so we do not know that yet. So it is very simple. So once again, for your VF, that is basically VI plus the acceleration times time. Transposing all of the values to the other side and rearranging this. So our VI is actually equal to VF minus AT. So with that, substituting known values, so our VF is now to be equal to 10 meters per second minus, so what is to be our acceleration? Our acceleration that we have solved for earlier is to be 1 meter per second squared. So 1 meter per second squared times t, and that is to be a total of 5 seconds. So with that, our answer here is now to be equal to, so 10 minus 1 times 5, so that is to be 5 meters per second. Okay, so take note that this is not equal to 0 because it is stated in the problem that it did not start from rest. And if it would be starting from rest, your VI should be equal to 0. So there.